could be essentially what your diagram looks like if you were to draw these vectors out. We are, of course, trying to find r. We can say that the 200 feet, this would be vector A, essentially, vector B, and vector C. So we can first say that vector A would be essentially 200 feet, all in the positive x direction, so I hat. Vector B would be equaling 135 feet multiplied by cosine of 30 degrees. This would be positive I hat. And then plus the same thing, 135 feet multiplied by sine. Rather, we could say feet multiplied by sine of 30 degrees times j hat. And this is essentially equaling, we could say 116.9 feet I hat, and then plus 67.5 feet j hat. Now the same thing for vector C. This is equaling 135 feet. This would be cosine of 40 degrees I hat plus 135 feet sine of 40 degrees negative j hat. And so this would be equaling 103.4 feet I hat minus, this would be 86.8 feet j hat. So r would simply be equaling a plus b vector plus c vector. And so we can see that solving r will be equaling, we could say the magnitude of r would be equaling the square root of 200 plus 116.9 plus 103.4 quantity squared plus this would be 67.5 minus 86.8 quantity squared. And so our magnitude of our vector would be 421 feet. And for our theta measurement, this would be arctan of the y component divided by the x component. So this would be 67.5 minus 86.8 divided by the x component of 200 plus 116.9 plus 103.4. And this is going to equal 3 degrees. But remember, we have a positive x, a negative y, so we're actually in the fourth quadrant. So theta would equal 3 degrees below the positive x-axis. And so this would be our final answer for the magnitude of the resultant vector. That is the end of the solution. Thank you for watching.